Okay. Before we begin, could you tell me uh, what's your goal and what do you hope to get out of these sessions?
Um, I guess get some basics on what coding is, what's the main languages I may wish to learn, and I don't know how you structure your lessons, but I don't know, learn as much as I can about coding in the time that I have.
Okay.
That's my goal.
Do you have prior experience with programming?
I'm actually the guy who wrote on your Reddit post that I use Linux. I'm actually on Linux right now, and
Okay.
so I have some experience just on some configuration files. So that kind of programming language, just editing, and also I am a PLC programmer, which is very different from normal line of code coding. It works way different. What works with the contacts and outputs. It's a graphical kind of interface you can you can program with. Yeah,
I see. Okay, cool, cool. All right.
yeah.
Uh, okay, to get us started, I'm going to send you a editor that works on the web browser.
Mm-hmm.
And if you could just open that up, I've just sent it on Zoom chat. If you could just open that up on a web browser and then share your screen
Yes.
with me.
Yeah. Okay. Let's share the screen. Okay, Windows. Let's do this. Okay.
Okay.
Okay. Can you see it?
Yes. Could you zoom in like two
Okay.
times?
Yeah. Um, like
Okay, one
this.
more time. Okay, I
Yes.
think that's great. Okay,
Okay.
to start with, I'd like you to click on the left window.
Mm-hmm.
Okay. Next, I'd like you to think of two big numbers and then add them.
Okay. So I'll just write the equation like very big or just big.
Just big.
Okay. Let's 2000 and I don't know 50
Okay,
plus. Oh, sorry. Plus uh 4000. I don't know.
very good. Okay, now there's a blue button at the top right of your window called Run. Let's click
Yes.
on that.
Yeah. He did the
Very
equation.
nice. Okay,
Yeah. Yeah.
so programming is like using a calculator, which is unsurprising because a calculator is a computer, right?
Yeah. Of course.
Okay. Let's try something different. Could we add a third number in there?
Yeah. So we'll do like I don't know 498 like this.
Okay, cool. Let's
Should
run
I
it.
run?
Yeah,
Yeah. Yeah. Yeah.
nice.
Oh, sorry.
Okay,
Yeah.
okay. Could we change one of those plus signs to a minus?
Yes. Which in this.
Okay. Oh,
Hmm. Ah, I didn't expect this actually.
oh, so what's happening?
Um, Says the plus and minus operations are at the same grouping level. In the parentheses to the group operations, add parentheses to to group the operations and make the order of the operations clear. Okay, so I should basically do like this in parentheses, and then the result of this subtracted by 498, right?
Let's try it.
Yeah. Okay.
Very nice. Yes, so that's the idea. So there's a convention in mathematics for order of operations. Are you familiar with
Mhm.
pandas or bitmas?
Sorry, I never heard about it.
Okay, that's okay. So idea is like we should multiply before we add first.
Of course, yeah.
Yeah.
Yeah, yeah, of
So
course.
there's a convention. The convention
Yeah.
does not exist here.
Mm-hmm. Okay, I
Yep.
see, I see.
The
Yeah.
convention
You have
does
to
not
specify it.
exist exactly. The reason why the convention does not exist is because there are many, many more operations in programming languages, like a lot. And to memorize
Okay.
all of them is very painful. In some
Yeah.
programming languages out there, you got to memorize them. There's no choice. In this
Mm-hmm.
one, you don't memorize them, but you have to specify the order of operations manually. It has to be clear.
Yeah, yeah. I see.
Okay, great. Could we multiply this whole thing with a different number?
Yes, sure. So I should put it this in parentheses, like
Okay,
this, I guess.
okay,
And then this, and I put an asterisk, and then I don't 4
very good. Let's see.
should work. Yep. Yeah, it
Very
did.
nice. Okay, so far so good. So right now we see like we're using this like a calculator without conventions of order of operations, and
Yeah.
it's able to give us the answers. Very nice. Let's
Great.
try something a little different. Let's delete everything.
Uh-huh.
Okay, I need you to humor me for a second. I want you to write two numbers separated by a comma.
Mm-hmm. Let's do and uh
Now, surround everything in parentheses.
okay.
And before the first parentheses, I would like you to write a few letters.
Mm-hmm.
M-I-N.
Sorry?
Oh, sorry. N-U-M.
N-U-M
Yep. Dash.
dash.
M-I-N.
Uh-huh.
Okay, before we run it, what do you think is going to happen?
I think it's going to specify that this is this and this is this. I think. I don't know exactly what this and this should be. Are they variables, maybe?
Okay. All right, let's run it and see.
Yeah. Huh.
234.
Huh. Interesting.
Okay. Okay, I would like you to keep changing the numbers to reverse engineer what this is doing.
Okay. Yeah. We'll try. So let's start by swapping them, or at least putting the bigger number second. Maybe that's.
Okay.
Let's put like this, maybe. What's the difference? Okay, still outputs. So what's the lesser of the two, basically?
Okay, let's test your hypothesis. Can we try changing 234 to something else?
Yeah, yeah, yeah. Right. 5. Yeah,
Hmm.
yeah.
Okay.
Great.
So you are
I
correct.
see.
It's giving us the minimum,
Yeah,
minimum of the two
yeah. Of
numbers.
course. Number minimum. Yeah, I see. I see.
Yeah, yes. There we go. So notice how the math operation here involves words. It's not plus or minus anymore.
Yeah,
It uses words.
yeah,
So that's
yeah.
the big takeaway. If you think about it, how many math operations could there theoretically exist?
Well, how many could there exist? Well,
Yeah,
I think infinite, maybe,
an infinite,
in
right?
this context. Yeah,
But there are only a finite number of symbols.
yeah,
And
yeah,
so
yeah,
we need words. We need to combine those symbols. So like NUM dash MIN, right?
yeah,
So
yeah, yeah. I see.
we can unlock the possibilities.
Right. Yeah, I
Okay.
see.
I would like you to add all of this to a different number now.
Okay. Well, I guess I would put this in parentheses and then do this. So I think it should output 55 because the output of this is 5 and then plus 50 it's 50. Yeah. Okay.
Very nice. Okay. Now let's try something. Could you delete the surrounding parentheses around nummin?
Yeah.
Yeah, let's remove it and let's just see what happens.
Okay, works anyways. Okay.
Oh,
Yeah.
why does it work? Why does it work?
um well, I think this is already an operation defined in it of itself, I think. So it knows it should do it first and then add it, maybe.
Okay. Another way I like to think about this is that the num_min has parentheses in it already.
Yeah.
So it
Yeah, you're
knows the
right.
605 is associated with num_min.
Yeah,
Yeah.
I see.
Okay.
Makes sense, yeah.
The same way we can add and subtract numbers together in one line, we can use add and num_min in one line. So we can mix and match these symbol operators with this worded math operations. Yeah.
Hmm. Yeah.
Okay. Can we try moving the plus 50 into inside the parentheses?
Yeah, we can.
Yeah, let's try.
Okay. Oh, well. Okay, this works. Great. Okay. Sorry.
Aha, okay, you
Yes.
saw it. Nice.
Yeah. Okay, yeah, works. I
Same thing,
see, I
right?
see. Yeah.
Okay.
So these are basically connected to this because they have a common comma
Yep.
between each other. And then this is separate because it has the plus sign, right?
Yes.
Okay. Yeah,
So
yeah.
it may
I
not
see.
seem different, but there is a difference compared to when the plus 50 is outside.
Mm-hmm.
When it's inside, the addition happens first. The addition happens and then the minimum.
Yeah.
Now, when the
Okay.
plus 50 is outside, the minimum happens first and then 50 is added to it.
Mm. Okay.
Okay?
Yeah.
Again, the
Yeah, yeah,
idea
I
of
see.
order of operations.
I see. I see.
Okay. So far we've been exploring the laws of arithmetic with this programming language. No different from a
Yeah.
calculator. Let's move forward in time a little bit to algebra.
Mm-hmm.
Let's delete everything, and I'd like you to write x equals 1.
Yeah. It equals. Sorry.
Oh, x.
X. Sorry.
Yeah, the letter x. Yeah.
X equals 1.
And then new line,
Yeah.
x. Okay, before we run it, what do you think is going to happen?
I think it will output 1 because this assigns the variable this variable, which is 1, and then
Okay.
this should output, I think, the the content of the variable.
Hmm. Okay, let's run it. Let's see what happens.
Yeah.
Yeah, as expected, right? So there's variable substitution. We see x, we see 1.
Yeah.
Okay. I notice you
Yeah.
use the
Yeah.
word assign. Interesting. Okay.
Hmm.
Uh, let's do something a little different. On line, can you create a new line after line 2?
Yeah.
And let's write,
Oh,
oh,
sorry.
before
After
that.
line 2, you said. Yeah.
Yeah.
Yeah. Yeah.
And let's write x equals 2.
X equals. Sorry. Equals
Yep.
2. Yeah.
Now, before we run this, what do you think is going to happen?
Well, this is going to be overwritten by this, so it will output 2 here.
Fair
Oh,
answer? Ah,
okay. So it says you can't declare it twice. Okay, I see, I see. Makes sense
yes.
too.
Okay. So this has different behavior depending on the programming
Mm-hmm.
language. In Python, for
I see.
example, it would have overridden it. Okay.
Okay.
So notice how it says
Yeah.
declaration, declare,
Yeah, yeah.
right? When you declare
Yeah,
something,
yeah.
you're saying like it is that and that's it. It cannot change.
Yeah.
It's like a declaration of independence. Once you declare it, you've declared it.
Yeah, yeah. I
Okay.
see it.
Okay, now back to what you said about assignment. Now it's not wrong, but there is a subtle
Mm-hmm.
difference. Because in other programming languages that would allow this, it would be called reassignment, where you assign for the second time.
Mm-hmm.
Uh,
Yeah.
but but we do say declaring here. because it has the
Yeah,
idea of like you do it once and that's it.
I see. So it's a constant, like you can change it
Exactly.
anymore. Yeah.
Exactly. Uh, there, I believe there is a way in this language to change it. It would have been called mutation, but that's in the future. We'll cover that in the future.
Okay. Yeah.
Yeah. Okay, let's delete line 3.
Okay.
And can we swap the two lines? Can we put x before x equals 1?
Sure.
Okay, before we run it, what do you think is going to happen?
I think it's going to have a problem because you're how do I say this? I'm interrogating it before it's been declared. I think maybe
Okay,
it doesn't work like that. Let's try.
that's right.
Yeah. Okay.
Yep.
I'm bound. I
So
think.
there's
I
a
see.
notion of time, right? There's
Yeah.
order of operations, but across multiple lines. We see x
Yeah.
before we see that x is defined as 1.
Yeah. Yeah. Makes
Yep.
sense.
Okay, let's swap it back. Let's put x below again. And can we change x to x plus 1?
Okay. So the this one
Yeah.
x sorry x plus one. So it should output two.
Okay, let's run it. See. Okay,
Yeah.
makes sense. So these variables and numbers can mix and match.
Yeah.
Okay. And if we change x equals 2, what would you get?
Three.
Okay, let's see.
Oh, sorry. Two.
Okay.
Yeah.
Okay, very good. So this is variables. Okay, let's try one more thing. Um, can
Mm-hmm.
we add a new line after x equals 2?
Mm-hmm.
And can we do y equals x?
Y equals sorry equals
Mhm.
x. Okay.
And then on line 4, can we change that to y?
Yes. Should be the same. The same output.
Okay, let's see.
Yeah.
Okay, you just
Yeah.
ran it,
Yeah.
right? Okay, notice how we can say
Yeah.
y equals x.
Yeah. So
So,
this takes
mhm,
the content of the variable, and then
mhm.
it's the same thing as x plus one. So it's the same output.
Exactly, yeah. So on line 3, when we say y equals x, y is going to be like, oh, what's x? X is 2. Okay, so y equals 2. Now,
Yeah.
past line
I
3,
see.
x and y are no longer related.
Mm-hmm. Yeah.
Yeah,
So
they're
yeah,
no
if
longer
I
related.
reassign x after this, it's independent from y. So y is going to remain 2, and then x, if I reassign it, well, I can't in this case, but
Yeah.
if it
With
was
mutation, you can. Yep.
reassignable, yeah,
Yeah, exactly. Yeah. So we'll revisit this idea in the future, but you already know it, honestly. But yeah.
yeah,
Okay.
okay,
So we've covered variables. Let's move on from variables. So we explored. So variables is a big part in algebra, and another big part of algebra is functions.
mm-hmm.
Let's delete everything, and I'm going to show you how to write a function. And you got to humor me for a
Yeah,
second because it's going to look very different from what you're used to. Okay, first write
okay,
fun space
mm-hmm.
f
Space,
opening parentheses x closing parentheses
mm-hmm.
colon.
Which is column again? Sorry,
Oh,
the
that's
dots, right? It's
yes,
dots,
that's the
right?
one.
Yeah,
Yep.
okay.
Okay, new line
Uh-huh.
x plus 1,
X plus, sorry, plus 1.
new
Yeah,
line
okay.
end. Okay,
I see.
notice how they're all highlighted now.
Yeah.
So the language knows that you have defined a function.
Mm-hmm.
Okay. Now let me ask you, what is a function?
A function, I think it's basically a snippet of code which can be run with options.
Hmm.
Is what I have in mind about this. I don't know if it's correct though. Like I can
That
recall
is,
this function and
yeah.
I don't maybe change this, and then if I change this, the output of the function is going to change. Maybe. I don't know.
That's a good answer. Yeah.
Okay.
So to put it differently, a function takes inputs and from the inputs produces an output.
Yeah. Okay.
Inputs to outputs, right?
Right.
Okay. So there are three parts to a function definition. The first is it has a name.
Mm-hmm.
In our case,
This
the
is
name
that.
of our function is f. Yep.
Yeah.
The second part is its inputs. In this case, there's only one and it's x.
Yeah.
Another terminology you might hear for inputs is parameters. We say the parameter of this function is
Mm.
x.
Yeah. Yeah. I think that's what I meant with options. Probably.
Exactly, yeah.
Yeah. Okay.
And the third part of a function is its body. So
Mm-hmm.
this is the chunk of code that is run,
Mm-hmm.
and then whatever its answer, that is the output.
Yeah.
Okay, if you run it here now, let's see what happens. Nothing,
Nothing.
right? Because we
Because I
don't use
haven't
the function.
assigned this.
Exactly, we haven't used it.
Yeah.
Let's create a new
Yeah.
line and let's
Mm-hmm.
apply the function. So in mathematical speak, we say we apply the function, but in
Mm.
programming,
Okay.
we say we call the function.
Okay.
So
Yeah.
let's call it, and we do that by first referring it by its name. So let's say f,
Mm-hmm.
opening parentheses, and
Yes.
now any number.
Okay. 5.
Okay, good. Let's close parentheses. Let's run it.
Yeah. Okay. So I'm basically saying that x is 5. So this is going to output 6. Yeah. Okay.
Excellent.
Great.
Yeah. So now we're finally calling a function.
Yeah.
And notice how there's variable substitution happening. When we say f of 5, x becomes 5, right?
Yeah. Yeah.
Yeah.
Yeah.
And there's the notion of like we didn't declare a variable x, we didn't say x equals 5. We just say f of
Yeah. Yeah.
5 and it sort of just happens.
Yeah. Yeah. I see. I see
Okay.
the meaning.
Okay. So notice how there are two windows. That's the left window and right
Yeah.
window. Okay, let's move to the right window now. I'd like for you to
Mm-hmm.
write f, opening parentheses, and any number,
Yeah.
a different number.
Okay. 8.
8. Perfect. Closing parentheses and hit enter. We get 9.
Mm.
Okay, a few
Okay.
things to see here. First is that notice how we didn't change our program, but we got a new number, right?
Yeah.
We didn't say x equals 8. We didn't delete anything. Our
Yeah.
program's
Yeah.
the same. We got a new number. As you said, a function is it's like it gives us a piece of code that we can reuse without changing it,
Right.
right? So that's one idea.
So this is basically a console, right? Like
Ah, okay. So that's
gonna
the second idea. We have some sort of console happening here.
yeah.
Uh, so notice how it is able to use the definitions from the left window.
Yeah. Yeah. Yeah.
So some terminology, these two windows, the window on the left, we call it the definitions window. You might also hear
Mm.
definitions pane, like pane on window. I'm just going to call it window,
Yeah.
definitions window. This is where we define our program. And whenever we click run, we're running the thing on the left.
Right. Yeah.
The one on the right, that's very similar to a console, we call it the REPL. REPL.
REPL.
REPL. The four
Okay.
letters.
Yeah.
R for read. It reads what you write. So f of 8, it reads that. E for evaluate. In program, evaluate is like simplifying. It takes what you wrote and simplifies it as much as possible. So f of 8, it turns it into 8 plus 1, it turns that into 9.
Mm.
Evaluate,
Yeah.
if you break up the English word evaluate, it also means to make a value. Like evaluate
Mm.
to make a value.
Yeah. Yeah. Right. Yeah.
That's why there's the word value inside evaluate. And the term value in programming is a term that's most simplified. So a number like 9 is most simplified.
I see.
1 plus 1 is not a value. 1 plus 1 is not a value because you can simplify it further. The ones in 1 plus 1 is a value. 1 plus 1 is 2.
I
2 is
see.
a value. Yeah.
Yeah.
So
I see. I see.
basically, evaluate, it computes the answer. So f of 8 is 9. That's the answer.
I see.
P
Makes
is
sense.
print. It takes the answer and prints it out. That's why we can see 9 there.
I see. Yeah.
L is
Yeah.
loop.
Yeah.
It keeps repeating this again and again. So we can write something else here. We
Mm.
can write 1 plus 1 here and hit enter.
Mm-hmm. Sorry. I
Yep.
keep switching up plus and equals. It's incredible. Okay. Yeah.
There we go. 1 plus 1 is 2. So yeah, we can keep doing this again and again. It's like a one-line program and we can keep running just by hitting enter.
Right. Yeah.
So notice how it's faster to get things working here.
Mm-hmm.
So a REPL
Yeah.
gives
Yeah.
us
Of course.
fast feedback, instant feedback at a click of a button.
Mm.
So not all languages
Yeah.
have this. This language is designed for beginners to learn quickly, and so this language has it.
I see.
Okay,
What
cool.
what is this language called? Pirate?
Oh, yeah, pirate, yeah. Pirate.
I see.
Yeah.
Okay. Okay.
Okay. So to summarize, we have basically used this like a calculator. We are able to perform arithmetic with numbers. We have variables, and we also have functions. We have explored the laws of algebra here.
Mm-hmm.
Okay. So
Yeah.
these are sort of the mechanics of using the language, but I wouldn't say that we are really, really programming yet.
Mm-hmm.
Okay, so I'm gonna shift gears a little bit and I'm gonna get into what I consider what programming is really all about. Let's delete
Mm-hmm.
everything in our program, and I want you to write the number 5.
Okay. 5.
Great. Okay, now I want you to run it.
Yeah.
Okay, 5. We say 5, we get back
Yeah.
5. Nothing surprising. Okay, now let me ask you,
Yeah.
what does 5 mean?
Um. What does 5 mean?
Yes, what does it mean?
Um. I don't know. It's basically an output. This is that what you mean?
Okay,
It's not a variable for sure.
okay.
Um. uh,
Okay, let me ask you something different
I
now.
can't say.
I
Yeah.
know, I know you can't say. It's a trick question actually. Let me ask you a different question. What if I
Okay.
say 5 degrees Celsius? What does that mean now?
Well, 5 degrees Celsius is basically a size which represents a temperature.
Okay, how cold, how hot something is. It means a little bit more now. Okay. How about
Well, yeah,
5,
of course.
how about 5 kilograms?
Yeah, it's weight.
Wait,
So
how heavy, how
we
light
have,
something is.
yeah,
Okay. But in all of these instances, it's 5. They say 5. But depending on the
yeah,
context, whether or not we say Fahrenheit, Celsius, or kilograms, there's a little bit more meaning to it, right?
yeah.
Okay, so there are two worlds. There's the world of information. This is
Mm-hmm.
ideas and facts about our real world. And there's the world of data. This is what the computer
Yeah,
sees. Now we see
yeah,
5
yeah.
degrees Celsius, but the computer sees 5. Just the number 5. That's data.
Right. Yeah,
We think in information, the computer thinks in data.
I see.
And
Yeah,
all of this sounds philosophical, but it's a very practical idea because
yeah, yeah,
my
yeah, of
core
course.
belief is that our role as a programmer is to facilitate the interaction between the world of information and the world of data.
I
Our
see.
job is to convert between information and data. We encode information into data. Another word you might hear is representing. We represent information with representations of data.
Yeah,
Another way of
I,
understanding everything we've done so far is that we have been encoding information as numbers, and we've been performing operation on the numbers.
mm,
Okay.
yeah, yeah.
Okay, I'm going to shift gears a little bit, but before I
Okay,
do that, our Zoom session's about to expire because I'm on a free tier. I'm going to close this
okay.
session and I'm going to send you a new link on Gmail. So take a look at your Gmail and I'll see you in a minute.
See you. Bye bye.
Okay. The pain.
Yeah,
Okay.
yeah.
All right, so we have been encoding information as numbers. Now,
Hmm.
can we encode all information as numbers?
All the information. Well, yeah, I maybe yeah. It may
Okay, why do you say
be
that?
more complex with the complexity of the information, but I think we should be able to.
Okay. Why do you say this?
Sorry, can you say that again? I didn't understand.
Oh, oh, why do you say that we can? Why
Oh,
can
oh
we?
yeah. Um, well, because if we can say or sorry, like make the computer understand what 5 degrees Celsius is, we can definitely make it understand more complex information. And then it's just a matter of scale, I think, so that we can define the um, the smaller parts of the information, like I don't know, bigger applications of the information. I don't know how to explain this, but
Okay.
I
But
think we
how,
should be able to.
but as numbers, only numbers?
Well, um, we should with only numbers, but not in programming. Like we basically do represent with zero and ones, but in programming we use other functions. I think
Okay.
to to shorten the process and make it understandable.
Okay. Okay, that's a good answer. A key idea here is that a computer is just a bunch of zeros and ones, and computers can do great
Yeah,
things, right? Now,
yeah,
my
of
next
course.
question is, do we want to encode everything as numbers?
Well, no, because they're less understandable.
Hmm. Okay.
Yeah,
For example, like you and I, we're talking right now, but we're not talking in numbers. We're talking in words, language.
yeah, of course. Yeah,
Yeah. So, numbers, everything can be encoded in numbers, but we don't want to because it's less understandable. Oh, here's another
right.
example. You know how they say the universe is just a bunch of particles?
Mm-hmm.
Well, in front of me is a table, but in the eyes of the universe, it sees a bunch of particles. The idea of a table doesn't matter to the universe. But for me,
Yeah,
I care that it's a table. That I think of it when I see it. I see a table,
yeah,
right?
of course.
Because it's useful to me.
Right.
Likewise, we think of things in higher terms. We don't think of things in numbers because that's how it's useful to us.
Yeah,
So there's this whole idea of understandability, the idea that a human being can understand something, you know?
yeah, yeah.
And when we choose to encode a piece of information, that understanding is also important.
Right.
Okay. So we have encoded everything in numbers so far, and we have discovered that perhaps we should encode things beyond numbers. But what does that mean and what does that look like? So I'm going to show you a different representation of information.
Mm-hmm.
Okay, can you delete that five?
Yeah.
Okay, write double quotes.
Yes.
Hello, comma space world,
Comma space world.
closing double
Yep.
quotes, and let's run it.
Okay.
Hello world.
Okay.
And we didn't
Yeah.
get back a number.
Yeah.
We got back something different. In fact, we got back a string of characters.
Yeah.
It's called a string. So this Hello World example is quite historical. There's a book in the 70s that used this example, Hello
Mm-hmm.
World. And ever since that day, every book, video course, university lecture, you name it, they all use this
First program
example.
is always print hello world. Yeah.
Exactly. It's a rite of passage. And so congratulations, you've hit this rite of passage. You're a programmer
Yeah.
now.
Thank you very
Okay.
much.
Oh, no problem. So this is a second data type. So when I say
Mm-hmm.
data, like a number is a data type, a string is a data type. A data type
Yeah.
is a classification of data. Okay. So hello world. So just now we saw that we can do arithmetic with numbers, but can we do arithmetic with strings? Can you add this string to another string?
Well, um, probably. I think. Let's try it. Let's do this. Is hello world. I don't know. Today
Okay,
should work. I think.
let's run it.
Oh, okay. Yeah,
Nice.
I should put a space here. Or okay.
Okay, great. Hello world today. Very good. So the same way we can add numbers, we can add strings.
Yeah.
Okay. Could we replace the plus sign with a minus?
Mm. Wow, I have no idea what this could do actually.
I don't know. Let's see.
Let's try.
Oh, what
Uh-huh.
happened?
Yeah. Says expression errored. The left side was this, and the right side was this. The minus operator, okay, expects to be given two numbers, so it can work with strings. The minus, I see.
Exactly. The computer also doesn't know what to do with this.
Yeah,
Yeah.
makes sense.
Okay. So we can add strings, but we can't subtract them. And so the operations, but we could subtract numbers. But so the operations for numbers and strings are fundamentally different.
Mm-hmm.
What makes
Yeah,
sense for one does not make sense for the other.
yeah.
Okay. All right, let's delete that. And I got another somewhat philosophical question. Could you write five in double quotes
Yeah.
and then run it? Okay,
Mm-hmm.
nothing special, right? Like the same way we can write hello world in string and run it and get it back, we can write
Yeah.
five in string and get it back.
Mm-hmm.
Okay, on a new line, can you write the number five, not in quotes?
Yes.
Okay, can you run it? Okay, so here we
Mm-hmm.
see five, one in string, one that is just a regular number.
Yeah.
Okay, I'm gonna ask you a somewhat philosophical question. I want you to ponder it. I have to get water and also use the restroom, which shouldn't take long. But think about the
Mm-hmm.
question while I'm away. Now that we have strings, and strings are a series of characters, and to write a number, we need to
Mm-hmm.
write a series of characters. Why do we need numbers? Why not use strings for everything? Any questions about the question?
Um. Well, I guess I don't actually understand the implication of how we're actually going to use the strings and their numbers in an actual program. So I don't I can't imagine in my mind right now how we could use one or the other, because
Okay,
basically I think a string um is kind of like a word. We could use it for I don't know a text box, but with this we could do calculations for I don't know if you're making a game geometry, um I don't know, placement, coordinates, I don't know. So it's very different in their kind of purpose, I think.
okay. Now, I was about to get water and use the restroom, but you basically answered the question. You're correct. They
Okay.
have
Okay.
the nature of the operations are different. They're operationally different. For example, we can't
Yeah.
subtract two strings, but we can subtract two numbers, right?
Yeah.
So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each. And as
Mm-hmm.
programmers, our
Yeah.
job is to determine what's the most appropriate data representation for a given piece of information, right?
Yeah. Yeah.
Okay. Um, okay, so those are two data types. We have numbers and strings, and we saw that we can perform arithmetic, well, quote unquote arithmetic for each of them. Uh, I'll now
Yeah.
introduce a third data type. So all these data types, they encode
Mm-hmm.
a very fundamental piece of information in a very fundamental way. So this third data type, I think you'll notice since you do PLC programming, it's been
Mm-hmm.
said that life is a series of decisions, and a decision is fundamentally yes or no. Yes, no,
Mm.
on, off, right, wrong, true,
True,
false.
false.
Yeah, true,
Yeah.
false. True, false rings a bell.
Mm-hmm.
These ideas of
Yeah. Yeah. Of
duality,
course.
very, very important in our
Yeah.
day-to-day life. The fact that this idea, our computer runs on these ideas, this ideas of duality. So in programming, we call these Booleans.
Mm-hmm.
Booleans,
Yeah,
and they're named after Boole, a mathematician who studied these things as mathematical objects. And
I see.
in programming, yep, they are true and false. Let's delete everything and let's write true. All right? Notice how
Mm-hmm.
it's red in color. It's a bit special. Let's run it.
Yeah,
True, we get it back.
and it's true.
So in this language,
Yeah.
true is a value. Can we replace
Yeah.
true with false? Yeah, let's run it. False.
Yeah.
Hmm. Okay, so we see the two booleans. They're both values. Special. Can we write false and true? That's A and D.
Um, should it be big or
Oh,
small
lowercase.
text?
Small text. Yeah, there
Lowercase.
we
Yeah,
go.
I don't know. I didn't know how to say that. Okay.
Okay.
And true.
Yep.
Okay,
Very
so
good.
this is an AND gate, basically.
Oh,
Okay.
yes. Oh man. Okay, yeah. Yeah, this is super easy for you then. If you already told me that. Yeah,
Yeah.
let's change the N to a R.
Okay. Oh, sorry. So it's
Yeah,
going
let's
to
change it to R.
output true, basically.
Yep.
Yeah. Okay.
Okay, the logic gates that you work with also exist in programming,
Yeah.
but we don't call them logic gates, we call them Boolean operators
Mm.
because they're not
Okay.
physical devices, they're conceptual tools. Yeah.
Yeah. Yeah. Yeah. I see.
So the same way we can do arithmetic on numbers or strings, we can also do arithmetic on Booleans. We can add Booleans together with
Mm-hmm.
these Boolean operators.
Yeah. Yeah.
Okay,
Yeah.
usually,
Yeah. As you said before, it's different operators and different rules for every kind of data. Yeah.
exactly, yes. So usually at this point, I pull up truth tables. You know
Mm-hmm.
what those are, right?
Yeah. Yeah.
Okay, if you told me
Based on the
Endgame, you definitely
different
know what they are.
yeah, based on the different combinations of these two,
Yep,
there's a table that represents every possible outcome based on these two variables, what they could
e-
be, and the resulting value in output.
exactly, yes. So usually I pull up a picture of truth tables and I show people and I tell them about it. But for you, I think you're the one who should be teaching me. Okay,
Oh no.
but here's what I'll say to like link your understanding of logic gates to what we're doing here. The first is
Yeah.
that remember how we said that computers are just a bunch of zeros and ones?
Yes.
So, and those logic gates, they are working with zeros and ones, right? Well,
Right.
electrical signals that are interpreted as zeros and ones,
Yeah.
right? Another way of understanding these logic gates is that there are functions, right? Inputs and
Mm.
outputs. Give me electrical
Yeah.
signals, I'll give you one electrical signal back, right?
Yes.
Okay. Yeah, okay, no, I thought I would say that. That's it. That's all I have.
No,
The logic
that
gates
makes
are
sense. Yeah.
conceptually functions. Yeah.
Yeah. Yeah.
Um, I say conceptually functions because there
Mm-hmm.
are some caveats that make them not functions, but I will get to that in the future.
Okay.
Should I get to that now? No, I'll get to that. I'll get to that in the future. I'll get to that in the future. Okay.
Sure.
Um, is that all? Okay, yeah. I think we spent very little time on Booleans just because I think you already know this by heart. For programming, you only need to know three. So we saw N and R. That's another one that is not. Could you write not true?
Mm-hmm. Yeah. Okay. So I'll replace this. Not
Yeah.
you.
Wait, is it?
Okay.
Wait, can you run it? Is it not not? It's not bowler, so I think I made a
Um.
mistake here. Can
Mm-hmm.
you run it?
Yeah. Yeah.
Oh,
Yeah.
wait, hold on, wait. Let me let me Google this. Wait, what? I thought it's not.
Yeah, I
Give me
would
one
assume
second.
as well. Yeah.
1 second. Oh, I didn't do my research.
Yeah. Who knows?
Oh, sorry. It's a not and parentheses. True must in parentheses.
Ah, okay. Yeah, yeah. I see.
Yeah. Okay. Sorry. Now I'll run it. Oh, no space.
Okay. Yeah. Yeah, so this is basically the biggest
There we go. Okay, if you run it now,
example
it
that
should
it's a
work.
function, basically.
Okay, there we go.
Yeah, yeah, works great.
Make sense?
Yeah, so this is basically the input to this function. Yeah, this is the best example to the example you made before. Yeah.
Okay. Um, and yeah, I think the reason why we need parentheses is just ambiguity, just to make sure like that true is associated with not.
Mm-hmm. Yeah.
Yeah. Okay. Okay, so there are three operators that you need to know as a programmer, not and or. So this programming language, I believe, only has these three. Let me check. I'm doubting myself. Yeah, it only has these three. But in other programming languages, you might find more. You might see an XOR, for example.
Mm-hmm.
Um, you don't really need to know the other Boolean operators unless you're into
Yeah.
electrical engineering or cybersecurity. So those three would
Hmm.
do for our purposes.
Um, I'm curious why specifically in cybersecurity you would need to know the other operators.
So a big part of cybersecurity, like the reason, it's okay. What is security? Well, security is like,
Um,
okay, yeah, let me ask you, what is security?
what is security? Is basically making a system as resistant to intruders from the net as possible. So you want it so you can't access what want to make it so someone who doesn't have access or the right privilege uh, to access what you don't want, basically, like in the easiest example.
Okay, that's a pretty good answer. It's not just the net, it's generalizable. For example, if I steal your laptop and
Yeah, of
I try
course.
to break into your laptop, like there's no network involved, but I'm still like
Yeah,
intruding
yeah,
into your
you're
system.
right.
Um, another thing about security is that you basically have this like system and you're trying to protect it from misuse. Uh,
Mm-hmm.
And what does misuse mean? There's a lot of context. Okay, but that's not the goal. So why is XOR important in cybersecurity? It's like if you remember how we say computers have a bunch of zeros and ones in
Yeah.
security, how does the misuse happen? It's when the creators of the system has one understanding of the program of their system, and the
Mm-hmm.
attacker finds a different understanding that is also true, and they're able to use that to their advantage to attack the system.
Yeah,
And
yeah, yeah.
fundamentally, since we say the programs are zeros and ones, they understand things at a very low level, and they're able to find
Mm.
operations that are able to exploit the system. Examples of these
Mm-hmm.
operations are bit operations,
Mm.
Boolean operators.
Yeah.
Yeah. And there are like
I see.
mathematical properties to these operators as well. For example, like XOR.
Mm-hmm.
And when you XOR two of the same value, it always gives you zero,
Yeah.
right?
Right.
Okay, I might be wrong with that actually. Wait, let me confirm if is that true. Let me check the truth table.
I,
I
I
haven't done this in
think
a
that's
while.
true. I don't use XOR daily, but I think that should be true
Let me check. XOR. Yes, XOR. XOR is the
because
only one where
it's
if you
exclusive. It's exclusive OR basically.
exactly,
So
yeah.
it's if it's the same in at the same time, that's the same value at the same time. It outputs zero all the time.
Yes, exactly. Yeah, that's the one. So XOR it's a trick that can be used to zero out something. You just XOR the
Mm-hmm.
same thing and it becomes zero. So it's a trick. So like there
Mm.
are like properties behind this mathematical this Boolean operators, and
Yeah,
you can use that. Well, in your day-to-day life, you can use them to like speed up your algorithm, but also like you can also use this to make use of these mathematical properties to break a system.
I see. I see. Well,
Yeah.
I'll understand it better in the future for sure.
I know, I'm just like all this is like probably just for you. Like actually, you run Linux, so maybe you might use this in the future. Just don't break into systems, please.
Yeah.
uh,
Okay.
but yeah, like I say this as an offhanded like when I say cybersecurity, I say it as an offhanded thing. You're the first person to actually ask into that. But yeah, that's information for you.
Well, yeah. Yeah.
Yeah.
Yeah. No, I thought this all was extremely interesting. Yeah, you've been a great teacher. Yeah.
Oh yeah, I mean, I don't mean to brag, but
Also,
you know, oh yeah,
also very enthusiastic with it, which I think makes a big part of of the teaching.
oh yeah,
You
of course,
pass on the enthusiasm. Yeah,
of
it's
course,
great.
man. I was not to brag, but I was voted as the best teaching assistant by my students in one semester.
Wow. Well,
I it
I
wasn't
can
like
see
even
that.
it wasn't even an official thing. They made their own vote.
Yeah.
Yeah, yeah,
Yeah,
it's like my
I
life
see.
achievement right there.
Yeah, yeah, I know, I can see that for sure. What did you major in again?
Computer science and game development.
Mm,
Yeah,
well, extremely cool. Yeah.
yeah.
Well, I tried my best to make myself be understandable in another language, which is not mine. And you've been very great for trying to make me understand hard concepts in simple language. And you were really great. Yeah,
No
I for
problem, man.
sure will book another lessons. Yeah.
Your English is excellent, by the way. I feel like you sound like a native speaker.
I'm trying my very best here. I have to put my all my concentration on my speaking right
Interesting.
now.
Okay, yeah, no,
Yeah.
your English is pretty good. Okay. All right, so I guess let's wrap it up here. We are running out of time. I like to end my
Yeah.
sessions by asking with the students, what is one thing you learned today that stuck with you?
What's one thing? I guess the difference. For sure the part of the function. So how we could use the function and how every operator is basically a function that makes it very much more understandable in computer terms. And also, well, just the clarification on the different types of data we can have. Also, the difference between data and information. Yeah, it
Hmm.
was a great. I don't know how to say this. Very clarifying. Yeah, it's put a better sense of the concept in my mind, so I have a better sense of the subject. Yeah.
Hmm. Okay. Okay. I don't usually assign homework unless you want homework. Yeah, okay,
I
that's
guess I'll. If you want to, I guess I'll try. For this week, I'll try.
okay.
If you want.
I'll again, like it's no pressure. Again, the pace at which you progress is completely up to you. I'll email you
Hmm.
something. If you have the time, you can do it. If not, it's okay too.
Yeah, that
Um,
works.
okay. All right. I think that's it. I'm very happy to be able to help you on your learning journey, and I hope to see you again.
Yeah, I hope to see you again as well.
All right. Bye
Well,
bye
bye
now.
bye. Bye.